Does it make sense? So it's, again, this renumbering proposition. You have numbers which were numbered 1, 2, k, and k plus 1 and so on, right? Now what are you doing? You're renumbering. You're numbering 1 by I1, 2 by I2, so on, k by ik. So remaining numbers should be numbered somehow. But of course you cannot repeat labels which you already used. That's it. Okay. David and Lucas. Lucas. Okay, that's you. You're done because you gave me some kind of a mixture of several things. Okay, here you go. Okay.
I think it might go.
Oh, you are here. I didn't notice you. Wait, I think you have one more coming, right? Or I gave it before to you.
Yeah, probably.
Maybe.
I think this is
Yeah, probably I gave it to you before. Okay, no, are you going to entertain me with questions?
I have more if you don't, but go ahead.
Yeah.
Are we going to go out of 2-3 now? Can I ask a question about permutations and cycles and stuff?
Which number?
No, just general stuff. What's the difference between sim S and SN?
What?
Sim S and SN.
Okay.
Is it just that?
Sim S is just more general notation.
Can I ask you if what I think is correct?
So
wait,
sim
Professor.
S is all bijections of the set S. What?
I just wanted to ask you if my understanding was correct.
Hmm?
So it's like you said, sim S is all the bijections of the set S, but Sn is of the set 1 to n, right?
Not necessarily 1 to n. Of any set of size n. You don't distinguish them.
Okay, go on. Tell me what you said.
It doesn't really, okay. So Sn, if you want to think about it as sim of 1 to n, it will be correct. If that's what convenient to you. Right? But of course, if you take any other set which consists of n elements, then sim of this set will be the same as n. What's the difference? What are you looking at? Suppose I have set of 2 elements which are labeled 1 and 2. I have bijections of this set, right? Now suppose I have a set of 2 elements which are labeled A and B. Is the group of permutations of this set and that set are any different? So that's what I'm trying to say. No matter how you label set with 2 elements, do they labeled? Are they labeled by 1 and 2, by A and B, by U and Sha, if you know such letters? You don't?
What language?
Okay, Shina.
Russian.
Right. How about Aleph Bet? Aleph Bet? What is Aleph Bet?
Alphabet?
It's Hebrew alphabet, anyway.
Hmm.
And Alpha and Beta would be Greek alphabet. Well, never mind. It doesn't matter. When you're talking about this group, the only thing which is important is the size of the set on which these bijections are defined. Right?
So when it's Sn, the size is n. When it's
Size is n and that's it. Is it 10 elements? How you label them is not really important.
When it's sim S, the size is unknown.
Hmm?
When it's sim S, the size
S,
is unknown.
we don't specify size of S.
So is that
It's just more general notation.
is that the biggest difference between the notations?
Hmm?
That's the biggest difference between the notations?
And that's it. It's just general notation. And these are particular examples of groups like this. Okay.
I have another one.
Okay.
Is
Is it better now?
Yeah.
Can we move on?
I had more questions, but
Go ahead.
I wanted to write this down first.
Okay.
I asked a question about writing the product of cycles as a cycle.
Hmm?
The writing the product of cycles as a cycle?
Okay, it's not necessarily true that product of two cycles is a cycle.
Okay.
Sometimes it is, sometimes it isn't. Say if you take two non-overlapping cycles, then their product is not a cycle, right? If you have something like this, 1, 2, and 3, 4, it's just union of two cycles of size 2. You cannot write it as one cycle. No, try to explain to me what are your problems.
Okay. What was the problem that we were talking about that in regards to?
You wanted to know if.
What problem were we talking about? 10, right?
Yeah.
Okay, well, we already went over 10, right?
Oh, that's what, yeah, okay. But that's what we talked, yeah.
Any,
From problem, yeah. Any permutation can be written
as
bunch of disjoint
joint cycles.
which are orbits. So what are, how cycles
Wait,
are?
can I ask you, if any permutation can be written as the product of disjoint cycles, permutations include cycles,
Of
right?
course.
So any cycle can be written as the product of disjoint cycles, right?
Any cycle can be written as product of disjoint cycles in the most naive way.
Itself,
This
and
cycle, and
identity.
that's it. And bunch of cycles of size 1, which we are not writing.
Is that the only way that it can be written as the product of disjoint cycles?
No. Oh, yes. I'm sorry.
Yes.
I'm sorry. As
It can't be
product
split
of
up.
cycles, no. As product of disjoint cycles, yes.
So it can't be split up if you wanted to keep them non-overlapping.
Yes, you cannot.
Can't split up a cycle. into
No, if
non-overlapping
you
cycles.
have a cycle, okay. If you have a cycle, you can write it in many different ways
Up to 3
as
orders.
product of cycles. But these cycles will be overlapping. Say, for example, our definition of even and odd permutations
Yes.
based on this. Because if we have a cycle of tens of length 10, we can write it as product of 9 cycles of length 2, for example.
9 transpositions.
9 transpositions, and then we know that oddity of cycle of size 10 is 1. It is odd. Okay? We can do it in many different ways. But of course, these transpositions will be overlapping. Okay, now think about it in different fashion. What is this, how we're representing a permutation as this product, or I can say union of disjoint cycles? We take an element from our set S, and so what is our data? We have set S and we have a permutation sigma. We're just looking at all orbits of sigma. So what do you remember what is orbit? What is orbit of permutation? In order to define an orbit, you have to take some element T here from this set and this permutation, then you have sigma in power I theta, where I is any integer. You have a bunch of elements, okay? And that's what is orbit of theta. Orbit of T, I'm sorry, on direction of sigma. So sigma is fixed in this consideration, and we're picking different elements in S. So S will be separated in different orbits. We proved with you don't remember it already, but we proved with you in the very beginning when we were looking at permutations that these orbits are not overlapping. They either coincide or just separate.
What's orbit? What's orbit? Have we ever learned about
All
orbit
this
before?
number, all these elements,
I don't
you
remember
fix.
orbit.
So this is orbit of T. So in order to define orbit, when you have a permutation, you have to pick some element in S, and all elements which are obtained from T by pushing it with sigma in any direction. Sigma, sigma inverse, not important. Sigma square, sigma cube, sigma in power negative. All these elements constitute orbit.
I don't remember.
What is orbit of a satellite? What is orbit of a satellite?
Its path that it follows.
Okay, so it's collection of all points in space in which the satellite appears, right?
Can I ask a question?
Sure.
Is orbit just going to end up being the set of elements in that cycle?
Yes, exactly. Cycle which includes T.
Which includes T.
Yes.
Right.
So that's what it is. And that's why we have these non-overlapping cycles. Because orbits are separate. And so you have T, you have its orbit. Put it on a shelf. You take other element which is not in this orbit. It has orbit, it doesn't overlap, next on the shelf, and so on. Okay?
Huh.
Does it make sense?
Okay.
What was your input? Okay. So that's, yeah. So you have to think about permutation and this bijection on a set. Okay? Bijection. It moves elements in the set. So this is your satellite. Yeah? This element, T. And now you're looking at all positions which you can acquire under this.
And then some other questions. So permutations form a group
Of course.
under composition of
Of course. Yeah.
permutation.
Permutations are just bijections, right? Bijections of a set to itself. It's functions which take elements of your set as input and give you elements of your set as output. So functions from set to set, but not any functions, only very special functions. One to one and on to. Bijections. Only we are looking only at bijections. Composition of two bijections is a bijection. Inverse for a bijection is a bijection. That's why they constitute a group.
And cycles form a group?
No. Cycles. Okay, we have a
Prior to two cycles
good
is not
mess
a-
in our head. Okay.
Hmm?
We have two separate things, which in our head are somehow mixed.
Are you going to say cycles and permutations? Or are you going to say?
Yeah.
Okay. So okay, let me try to. So we have two objects. We have set S, and we have group of permutations on this set. Okay? Okay? So cycle is a bunch of elements of S. Okay? That's what it is, right? Say, when you write 1, 2, 3, and your set S is 1, 2, 3, 4. What is this? I understand why confusions. So what I wrote here, 1, 2, 3. 3 elements, right? Now, when I write this one, unfortunately, it's kind of confusing terminology. So what is written here is permutation. It's not now 1, 2, 3 elements of this set. It's element of this object. Just convention. And you know how this permutation works, right? It sends 1 to 2, 2 to 3, 3 to 1.
Yeah.
Okay. So unfortunately, well, okay, let's separate it. So let's call 1, 2, 3 orbit. And you insist that we didn't talk about orbits before, right?
I don't remember.
Okay. And cycles. So orbits then are elements of, yeah, subsets of S, and cycles are permutations here. Which reminded me about one homework question, where this confusion was very well sort of exhibited by you. The question was like this. Suppose I have an element S and S. Okay? You were supposed to show that if you consider all permutations of S, of big S, with additional property that tau of S is S, constitute a subgroup. Do you remember this question? Okay. So, even those who wrote all right words, I was not 100% sure that you completely understand what's going on. Because there is tendency to mix bijections and bisections. So what is it? You're looking at all bijections, which send element S to itself. Okay, so it's bijections with some restriction. Okay, so then you're discussing whether this restriction is such that resulting bijections constitute a subgroup, which is to say closed under composition and undertaking inverse set.
So for those, if for like tau, it's just going to be kind of whatever bijection takes it to itself. So it's just going to be tau, like n, I guess, or something like that.
I don't understand what you're trying to say.
So
Try again.
it just would, tau is just going to take it to itself. So it's going to.
Tau is going to take one particular element. This is small s. If I would write tau of large S is S, it's no restriction whatsoever, because it's a bijection. Okay. So what I want you to think about at home is that if now instead of S, I would consider a subset of this set, and then I have only those taus such that tau of A is equal to A, it is also a subgroup. Okay. So, but you have, when you are talking about bijections of a set, you have to keep these things separately. They are elements of your set, which are like arguments for your function, right? Your function takes these elements of your set as input. And then there are these functions, and these are two separate things. And I was under the impression that some of us at least somehow confused them completely. Okay. Next question.
Wait, I don't know if mine was answered.
What?
I don't know if mine was answered.
Which was your question? You already forgot?
Set our cycles groups.
Yeah, just do cycles from a group.
Do cycles form a group? You have to be more specific. What
Under
you're
the
asking.
operation composition,
Okay.
cycles.
Product of two cycles is not necessarily a cycle.
So they don't.
So if you're looking only at permutations, which are cycles, just one cycle, that's what you have in mind, then certainly it's not true. And the simplest example is take in S4 this cycle and this cycle. These are two cycles, right? But what is their product? They're together. 1, 2, 3, 4. It's not a cycle. It's two cycles. Okay? So this is a subset which is not closed under our multiplication.
What's their product again?
1, 2, 3, 4.
Oh, that's not a cycle?
Isn't it two cycles?
Yes, so you want to do two cycles again.
Product of this and this
Two cycles and
is this. Is it a cycle?
Oh, can't you combine those into one thing?
I can.
Huh?
It's not up to me, even.
how
How can I combine it? What do you want me to combine? What do you want me to write here instead of it? That's the correct answer. You want me to write wrong answer?
No, but if you multiply one versus
That's it, you know. Composition of permutations. First one permutes 1 and 2 and keeps 3 and 4 in place. Second one permutes 3 and 4 and keep 1 and 2 in place.
You can't write in one notation?
Because of disjoint.
This is one notation.
What's that parentheses?
You want me to put parentheses here? Okay.
No,
parentheses here.
I was wondering
Change
if
the
you
thing.
I was wondering if you could only use only one set of parentheses.
Of course I cannot.
Well, if you do it.
Look,
once,
I
you
already
can-
have it. Look, you want me to write something as one cycle, which it isn't one cycle. So how can I do it? Beats me. Okay. You know, it's kind of a philosophical thing. It is what it is. It isn't something else.
Well, that makes a lot more
I
sense to
think
say it
it
that
was
way.
used in some film by Fellini, you know, don't you please remember? There is some profound wise man and he shows apple to his disciples and he asks, what is this? And they're, of course, you know, running in circles to give some witty answers. And then he says, this is an apple. Which is completely accurate. You know? This is this two cycles. How can I help you more?
I think I'm good for now. Next.
Now it's your turn then, if you're good for now.